Hi, welcome to T1 Academy. So, from now onwards, we are going to start a series of sessions based on the quantitative aptitude. In that, our first topic is number system. Number system, we will start discussing from number system concept. See, for each and every topic, we will start discussing from the basic concepts and we will try to learn the toughest problem. So, in this manner, we are going to learn the entire concept, right? Now, see here in this number system is the most important and basic thing for us in the entire quantitative aptitude portion. If you are really good in this number system, then later we can easily solve all the remaining questions, all the remaining topics. So, see here in this number system, we will start learning from the number classification. Generally, any number, we can take it as in the form of some a plus ib. Okay, if I take any number in the form of a plus ib, then what we can say is a is a real number and b is an imaginary number. A is real number and b is an imaginary number in this case, right? So, a here and we will have b here. Next, anyway, we will not bother about these imaginary numbers in our number system concept. We only concentrate on the real numbers. Now, when it comes to this, we only observe only one thing in this case, that is I square is equal to 1. This is the only thing which you should know in case of imaginary numbers, nothing more than that. Now, when it comes to these real numbers which is further segregated into two things. One is irrational numbers and the other one is rational numbers. So, what is meant by rational numbers? All the numbers which can be written in the form of p by q are called as rational numbers. So, any number which can be written in the form of p by q is called as rational number. Now, what is meant by rational number? Very simple. The numbers which cannot be written in the form of p by q, okay, cannot be written in the form of p by q, we call that as irrational number. And when it comes to these irrational numbers, very less frequently we will use these irrational numbers. We mostly concentrate on the rational numbers. Now, when it comes to these rational numbers are further desegregated into two portions. One is fractions and the other one is integers. Now, see here this fraction. We all know what is meant by fraction. Anything we could write in the form of p by q in general terms. See, actually any integer can also be written as p by q. The reason is by 1. You can take it as by 1. But in general, we call the normal p by q's as fractions. Now, what is meant by proper fraction, improper fraction, and we will have one more thing, that is mixed fraction. Now, what is this proper fraction? For example, if I have, we will take that 2 by 3 or else 5 by 6, 4 by 5, something like this. So, these are called as proper fractions. If denominator is greater than numerator, we call that as proper fraction. Now, what is meant by improper fraction? Improper fraction means, see, I will add another slide to write all these things. See, now what is meant by proper fraction? In case of proper fraction, our denominator will be greater than the numerator. That means, if I write something like this, a by b, then in these cases, b will be greater than a. Next, when it comes to improper fraction, if we have a by b, then we can write, if in this case, if a is greater than b, that means my numerator is greater than the denominator, then we call that as improper fraction. So, proper fraction. What is meant by proper fraction? Means if my denominator is greater than numerator, that means if it is a by b, that implies b should be greater than a, then we call that as proper fraction. Next, what is meant by improper fraction? Right? A by b, that implies if my numerator is greater than denominator, then we call that as improper fraction. Now, we will see some examples of this improper fraction. Take for example, we can say 3 by 2, 5 by 4, 6 by 5, all this comes under improper fraction cases. Now, what happens is generally we will not write our answers in the form of improper fraction. We will convert them into the mixed fraction. How we convert them? We will write that as 1 by 2, next 1 by 4, 5 1 by 5, sorry, 1 by 5, 1 by 5. In this manner, we will convert our improper fraction into mixed fraction. See students, in general, in any mathematics examination or whatever it is, we never write our answer in improper fraction. We always convert the improper one into mixed fraction and then only write our final answer, right? Now, we will go back to our previous one. Now, see here, as just now we discussed about this proper, improper and mixed fraction. Next, when it comes to these integers, we know actually we have negative integers and whole numbers, negative integers and whole numbers, negative integers as well as whole numbers, negative integers as well as whole numbers. The reason is whole numbers means here it also includes 0, 1, 2, 3, 4 and so on. Remember one thing, 0 is neither positive nor negative. 0 is neither positive nor negative. That means actually what we need to write here is negative integers, 0 and positive integers. Negative integers, 0 and positive integers, but 0 and positive integers together we call them as whole numbers. So directly I have written here whole numbers. Whole numbers. Next, whole numbers are divided into two portions. One is 0 and the other one is natural numbers. Natural numbers. We all know what is meant by these natural numbers. Any counting number we call that as natural number. Okay. Any counting number we call that as natural number. Next. Now, see here. So, now our natural numbers. Further segregation. How these natural numbers are divided means based on the factors. Based on the factors, these natural numbers are divided further. So, what are those? See here. Prime numbers, 1 and composite numbers. Composite numbers. Okay. Now, prime numbers. So, we all know what are called prime numbers. Any number which have exactly two factors is called a prime number. Any number which have exactly two factors is called a prime number. Is called a prime number. Next, 1. 1 is neither prime nor composite. The reason is 1 has only one factor, that is 1 itself. Next, composite number, any number which have more than two factors. In composite numbers, more than two factors. More than two factors, we call them as composite numbers. We call them as composite numbers. Right? Next. Now, there are some properties of these prime numbers. What are those properties means? Having exactly two factors, we call that as prime number. Next, 2 is the only even prime number. Okay, apart from 2, all the remaining prime numbers are odd numbers. Next, the only prime number ends with 5 is 5 itself. There is only one prime number which ends with 5, that is 5 alone itself. Next, all the other prime numbers ends with 1, 3, 5, 7 and 9. Okay, except 2 and 5. Actually 2 is also there, except 2 and 5. All the remaining prime numbers either ends with 1, 3, 7 and 9. Next, all the prime numbers which are greater than 3 can be expressed as 6k plus 1 or 6k plus y or 6k minus 1, where k is a whole number. Where k is a whole number. So, all the prime numbers usually greater than 3 can be expressed in this form. Okay, right. Next one. See, this is not whole number, natural number. Natural number. Next one. Now, see here. See, we know that prime numbers will have exactly two factors, whereas composite numbers will have more than two factors. Similarly, there are some particular set of numbers who have exactly three factors. What are those numbers means? The squares of the prime numbers. The squares of the prime numbers will have exactly three factors. The squares of the prime number will have exactly three factors. Okay, so We will have exactly 3 factors. The factors of p square. That means take for example, we will take what is the square of 2? 2 square is 4. 2 square is 4. What are the factors of 4? What are the factors of 4? 1, 2 and 4. 1, 2 and 4 are the factors of 4. Similarly 3 square. That is 9. What are the factors of 9? 1, 3 and 9. See 5 square. 5 square is 25. What are the factors of 25? 1, 5 and 25. Remember one thing very carefully. Squares of the prime numbers will have exactly 3 factors. Don't take 4 square and tell that it is not having exactly 3 factors. 4 is a composite number. 4 is a composite number, so we cannot take 4 in this case. Now, and remember one more thing, and what are those factors? Even we can tell their factors. Those factors are p square, p and 1 itself. Now, please see here, p square means 4, 2 and 1. Next, similarly 9, 3 and 1. 25, 5 and 1. These are the square factors of those numbers. These are the factors of those numbers. So, squares of prime numbers will have exactly 3 factors, and those factors are what? P square, p and 1 itself, where p is a prime number, Next one. See, we will see some questions now. A prime number contains the digit x at units place. How many such digits of x are possible? That means there is some random prime number. It has some units place as x. So, what are the chances they are asking us? Just now we have seen in our previous slide. So, what are the chances of our unit digit for any prime number? 2, 5, 1, 3, 7 and 9. So, total how many possible unit digits are present for me? 6. So, our answer will be 6 here. Next one. Find the smallest 3-digit number which have exactly 3 factors. See, first of all, just now we discussed which type of numbers will have exactly 3 factors. Squares of the prime numbers will have exactly 3 factors. Okay, good, superb. But what they asked us, the smallest 3-digit number. Usually, what is the smallest 3-digit number? It is 100. Smallest 3-digit number is 100. But 100 have many factors. 100 have many factors like this. See, 1, 2, 4, 5. Like this, if you go on writing in this manner, 10, like this, 100 will have many factors. But we want it should have exactly 3 factors. So, what is that number? That number is nothing but a perfect square number, that too a perfect square of a prime number. So, we will see. Actually, 100 is square. When you do what, which number square is 100? 10 square is 100. So, next number, after 10, what is the first prime number do we have? 11. So, we will check for 11 square. 11 square is what? 121. Then obviously, 121 will have 3 factors, and what are those factors? 1, 11 and 121. So, the smallest 3-digit number having exactly 3 factors is 121. 121. 121. Next one. Now, we should know some of the basic and important things while solving the problems, and those are these things, right? Relatively coprime or coprime. See, by seeing the word coprime, this coprime is very, very important. Why? Because later in many concepts we will use the help of these coprimes. What is meant by give these coprimes? By seeing the word prime, don't get confused, these are prime numbers. Not like that. It is based on the HCF. Okay. For any two numbers, if their HCF is 1, then we call them as coprimes. See, actually speaking, there will be slight difference between relative or coprimes, but in general we will not bother about them. We will consider both as coprimes, and then we will solve the problems, right? HCF is equal to 1. So, take any two random numbers, whether it is a prime number or composite number, both the prime numbers. Anyway, both the prime numbers will be coprimes to each other, and a pair of prime number and a normal composite number will be coprime to each other. Why? Because their HCF will be 1. So, we will take some examples. What I have taken here is 3 and 5 coprimes. 5 and 7 are coprimes, 11 and 15. Actually 3 and 5, 5 and 7, these are what? Prime numbers. So, by default they becomes coprimes. Now 11 and 15, actually speaking 15 is not a prime number, but 11 is a prime number. So, a pair of a composite number and prime number also becomes coprimes. And similarly, I will take 8, 9. 8, 9. 8, 9 are also coprimes. Even though both 8 and 9 are composite numbers, but their HCF is 1. So, I can say that 8 and 9 are coprimes to each other. And remember one simple thing here, the thing is, in number system, any two successive numbers are co-primes. Any two successive numbers are co-primes. That means 10, 11, 11, 12, 13, 14, 15, 16, 17, 18. Like this, take any two successive numbers. Those two numbers will be always co-primes. Right? Next, twin primes, whose difference will be 2. Then we call them as twin primes. The numbers whose difference, the prime numbers whose difference is 2, we call them as twin primes. Next one. These are important, some of the important formulas for our number system. What are those? Sum of first n natural numbers, n into n plus 1 by 2. Sum of squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6. Next, sum of cubes of first n natural numbers, n into n plus 1 by 2 whole square. N into n plus 1 by 2 whole square. So, this is the square of this one. Okay? Right. Next, divisibility rules. Divisibility rules are also very, very important for us. Why? Because they ask some questions from these divisibility rules also. We all know a number is divisible by 2 if its unit digit is even or 0. Even number or 0, then obviously that number is divisible by 2. Similarly, what is the divisibility rule of 3? A number is divisible by 3 if the sum of the digits are divisible by 3. Sum of the digits means nothing but, for example, I will say that is 123 divisible by 3 or not. How I need to check this one means sum of the digits in the sense 1 plus 2 plus 3. What is the sum I will get here? 6. You need to check whether 6 is divisible by 3 or not. Yes, 6 is divisible by 3. So, that means obviously 123 is divisible by 3. In this manner, we will check the divisibility of 3. Next, what is the divisibility rule of 4? A number which is divisible by 4 if the last two digits are divisible by 4 or if the last two digits are zeros. That means whatever may be the length of the number, for example, take for an example 1, 4, 3, 2, 6, 4. The number is very huge, okay, but I only concentrate on the last two digits. I will check whether the last two digits are divisible by 4. Is 64 divisible by 4? Yes. Then obviously the entire number is also divisible by 4. If 64 is divisible by 4, the entire number also divisible by 4. Or else sometimes we may also have like this 1, 2, 3, 4 and 2 zeros. So, the last two digits are 0 right here. So, by default I can say that this number is divisible by 4. Next one, divisibility rule by 5. A number which is divisible by 5 if its units digit is 5 or 0. Any number whose units digit is 5 or 0 except 0, that number will be divisible by 5. Next, divisibility by 6. A number is divisible by 6 if it is simultaneously divisible by 2 and 3. That means any number which is divisible by both 2 and 3. By both 2 and 3, then that number is divisible by 6. Both 2 and 3, that number is divisible by 6. Next one, divisibility rule of 7. What we need to do is this is little bit complicated, and the thing is we will not use this divisibility rule of 7 that much frequently. Okay, a number is divisible by 7 if its units place is multiplied by 2 and subtracted from the remaining digits, and the number obtained is divisible by 7. That means it is like a continuity chain. That means, for example, I need to see there is a number like this 1428. I need to check whether this number is divisible by 7 or not. What I need to do is 142. I need to take the units place and multiply it by 2. So, 8 2s are 16. I need to subtract it from 142. Okay, 142. If I subtract it from 142, what I will get here? 126. We will get here 126. Now, 126 is divisible by 7 or not? We will see. Yes, 126 is divisible by 7. So, this number is also divisible by 7. In this manner, we will see whether the number is divisible by 7 or not. Very less frequently, we will use the divisibility rule of 7. No need to worry. Next, what is the divisibility rule of 8? Very simple. This one is similar to 4. In case of 4, we check the last 2 digits. In case of 8, we will check the last 3 digits. If the last 3 digits are divisible by 8 or the last 3 digits are zeros, then I can say that number is divisible by 8. Next one, divisibility rule of 9. This one is similar to 3. In that case, what we have done, after adding all the digits and after getting the sum, we checked whether it is divisible by 3 or not. In this case, we need to add the same all the digits and we will check whether it is divisible by 9 or not. If it is divisible by 9, then it is divisible by 9, else it is not divisible by 9. Next one, divisibility by 10, very simple and easy. If the unit's digit is 0, then that number is divisible by 10. Next, what is the divisibility rule of 11? So, what we need to do is, for example, if I want to check 1, 2, 2, 1 is divisible by 11 or not. From left side, from right side, you need to start writing the numbering of their positions. 1, 2, 3 and 4. These are 4 positions for me. Now, I need to add the odd positions and even positions separately. So, what are odd positions for me here? 1 plus 2. And what are even positions for me? Same, 2 plus 1. So, what is the difference between their sums? It is 0. The difference between their sums should be either 0 or 11. Then that number is divisible by 11. Right? Next, divisibility by 12. Now, see here students, from here onwards, we need to tell the divisibility rules very quickly and randomly. Why? The reason is, any number which is divisible by both 4 and 3, similar to 6. In case of 6, any number which is divisible by both 2 and 3, then that number is divisible by 6. Right? Same case here also. If a number want to be divisible by 12 means, what we will do is, it should be divisible by both my 3 and 4. Now, see here students, actually, sir, 12, if I want to split 12, what I can write here? I can write it as 1 into 12. I can write this one as 2 into 6. And I can write this one as 3 into 4. So, students, my suggestion is always we should take the pair which are co-primes to each other. We need to take the co-prime pair. See here, 1 and 12, anyway it is no use. Anyway, once again you need to check the divisibility with 12, so we will not use this one. These are co-primes, but we will not use. 2 and 6 are not co-primes, but 3 and 4 are co-primes. So, that means what we will do is, we will check the divisibility with 3 and 4. Similarly, if you want to write the divisibility for 18, divisibility rule for 18. So, in general 18, how you can write? 1 into 18, 6 into 3, 2 into 9. So, here also the same thing. We will not bother about these two things. We only consider 2 into 9. That means, we will check any number which is divisible by both 2 and 9, then that number is divisible by 18. Next, divisibility by 13. This one is also the similar to our divisibility rule of 7. Now, see here, in case of 7, we will multiply the unit digit with 2 and then we will subtract it from the total number. In case of 13, we will multiply the unit digit with 4 and we will add it to the units place. And this one also we will use very less frequently, so no need to worry about that one. Next, divisibility by 14. Just now I told you 14, how you will get 14? 2 into 7, 2 and 7 are co-primes. So, any number which is divisible by both 2 and 7, that number is divisible by 14. 15, 5 and 3 are co-primes. So, any number which is similarly 16. Last 4 digits are divisible by 16. See, it is like a chain for 4, 8 and 16. If you observe for 4, we will check the last 2 digits. If you observe for 8, we check the last 3 digits. For 16, we check the last 4 digits. Or 4 digits are zeros. Nothing to worry about it. Right? Now, these are the things about the divisibility rules. Now, we will solve some of the basic questions which was asked in some other examinations, as well as we will see some of the questions based on this divisibility rules. Right. Now, see here, sum of two numbers is 29 and one number exceeds another by 5. Find the numbers. Let us assume that two numbers are x and y. So, x plus y is equal to 29 and one number exceeds another by 5. That means what it means? I can write x is equal to y plus 5. X is the biggest number among these two and I can write x is equal to y plus 5. Now, I will substitute in this. Y plus 5 is equal to 29. From this 2y is equal to 24. So, y value becomes what for me? 12. Y value is 12 for me. If y is 12, what about x? X becomes 17. So, the two numbers for me here are 12 and 17. See students, we will solve the questions from the basic to the toughest one, as we have earlier discussed. Right? Next one. 4 times of a number reduced by 5 equals 19. Find the number. Okay, 4 times of a number reduced by 5. What it means? There is a number x. 4 times of a number means 4x. And it is reduced by 5. What is the meaning of reduced by 5? Subtracted by 5. That means 4x minus 5. And it equals to what? 19. It equals to what? 19. So what we can write? 4x is equal to 24. X value will become 6 for me here. So the number is 6. Right? Next one. What are those two numbers whose sum is 58 and the difference is 28? Okay, they given us about two numbers whose sum is 58 and difference is 28. So x plus y is equal to 58 and at the same time x minus y is equal to 28. So simply two equations. See, generally when you have two unknowns, we require two equations to solve. If you have three unknowns, we require three equations to solve. Anyway, here we have two unknowns, we have two equations also, we can easily solve them. So if I add these two equations, what happens? Plus y minus y will get cancelled, so that 2x is equal to 58 plus 28. What you will get here? 86. So x value will become 43 for us here. If x is 43, what about y? Y is 15. Simply substitute this x value in either of these two equations, you will get y value as 13. Next. If a two-digit number, the sum of two digits is 8. If 18 is added to the number, its digits are reversed. Find the number. This is very, very important, students. Why? Because nowadays they are asking many questions based on this type of shuffling. Even in UPSC CSAT paper also they are asking some questions from this one. Okay, generally any two-digit number you can assume that as xy, and at the same time this is two-digit number. If you want to assume a three-digit number, you can assume that as three-digit number as xyz. There is no wrong in that, xyz. But when you perform any mathematical operation, while assumption you can take xy and xyz, there is no wrong in that. But when you perform a mathematical operation, what you need to do is, you need to take that as y is in units place and x is in tens place, right? So what I will write? X into 10 plus y into 1. And similarly, please see, this is a three-digit number. Z is in units place, y is in tens place and x is in hundreds place. How I will write that one? X into 100 plus y into 10 plus z into 1. So this is the way to assume the two-digit number, three-digit, if it is required a four-digit number also, the same process. While assuming, you can assume them as xy or xyz, but while performing the mathematical operation, you should definitely take them as x into 10 plus y into 1 or something like this. Okay, now we will come to our given question. What is the given question for us? In a two-digit number, the sum of two digits is 8. Okay, that means let number be xy. Two-digit number, right? Just now I told you, I will take that as xy. Now, sum of the digits means x plus y, that is 8. Okay, superb. Next, if 18 is added to the number, its digits are reversed. That means what he is telling us, when xy is added with 18, it is becoming yx. It is becoming yx. That is the thing he is telling us. That means the digits will be reversed. So while assuming, you can assume it as xy, but while performing, as I already told you, we should not do in this manner. Definitely we should follow the basic method. What is the basic method for me? We all know what it is. 10x plus y plus 18 is equal to 10y plus x. 10y plus x. So that means I will send this to this side and 18 to that side, or you can send this to that side, whatever way which you want. Now I am sending 18 to that side and 10y to this side. When I do that, what I will be left here is 9x minus 9y is equal to minus 18. 9x minus 9y is equal to minus 18. Why? Because when I send 10y to this side, it will become minus 10y, so minus 9y. And when I send x to this side, it will become minus xy, so 10x minus x, it will become 9x, right? So when I take 9 common here, 9 times of x minus y is equal to minus 18. So x minus y will become what? Minus 2. X minus y will become minus 2. Now you have x plus y and you have x minus y. Simply solve these two equations to get the values of x and y. So, x plus y is equal to 8 and x minus y is equal to minus 2. When I add these two things, plus y minus y will get cancelled. 2x will get as 6. 2x value I will get it as 6. So, x value becomes 3 here. If x value is 3, what about y? Y value will become 5. Y value becomes 5. So, the number will become what for me? 35. The number is 35. So, required number is 35. 8 times of a number reduced by 10 is equal to sum of 6 times of number and 4. What is the number? See, 8 times of a, let us assume number is a. 8 times of a number is reduced by 10 means 8a minus 10. This is equal to sum of 6 times of a number, that is 6a and 4 plus 4. That is a given question. 8 times of a number is reduced by 10 and that is equal to sum of 6 times of a number and 4. So, this is the equation. So, what you will get if I send this one to this side and 10 to that side, 2a is equal to 14, a is equal to 7. So, required number is 7 here. Required number is 7 here. A number consists of 2 digits whose sum is 9. If 27 is subtracted from the number is reversed. Same question which we have seen previously. Okay, sum of 2 digits is 9. So, I will take that number as xy. So, x plus y is equal to 9. Next, if 27 is subtracted from the number, its digits are reversed. That means what? 27 subtraction means 10x plus y minus 27, that is equal to 10y plus x. Why? Because xy was changed to yx. Now, same thing, 27 I will send to that side and I will send the remaining things to. So, what I will get here? 9x minus 9y is equal to 27. From this, x minus y is equal to 3. The reason is I will take 9 common and I will send to that side. It will get cancelled. I have x plus y and x minus y. Y is equal to 9. X minus y is equal to 3. Plus y minus y will get cancelled. So, what you will get here? 2x is equal to 12, x is equal to 6. If x is equal to 6, what about y? Y value becomes 3. So, my required number is 63. My required number is here 63. 63. Questions based on divisibility rules. Now, find the value of star for which 5967 star 13 is divisible by 3. So, they are telling that there is a number, this number which is divisible by 3, which is divisible by 3. Now, we will solve that question. So, what is the divisibility rule of 3? Sum of the digits should be divisible by 3. That means 5 plus 9 plus 6 plus 7 plus star plus 1 plus 3. It should be divisible by 3. Now, what happens? What is the sum I will get here? 5 plus 9, it is 14. 14 plus 6, it is 20. 27, 28 and 31. So, now I have 31 plus star by 3. 31 plus star should be divisible by 3. 31 plus star should be divisible by 3. So, how in place of star, what are the values I can take here? In general, we will have different options in the examination. So, you simply put each and every option there and cross check it. But here we don't provide any options, right? So, what I can take in place of star? I can take 2, right? If I take 2, 31 plus 2, it is 33. Yes, 33 is divisible by 2, 3. Next, if I take 5, 31 plus 5, it is 36. Yes, 36 is also divisible by 3, or else I can also take it as 8. Why? Because 31 plus 8, it becomes 39. So, that then also it becomes 39 is also divisible by 3. So, there are 3 chances. So, there will be 2 types of questions here. The first type is question is, what is the value of star? So, in options they will give either of those 2, 5 and 8, and we will put that values and we will verify it. And the second one is, how many values of star is possible? How many values of star is possible means how many values? 1, 2 and 3. There are 3 values which are possible in place of star. That is the case. That is the case. If you want to solve it more quickly or any other using any simple shortcut means, directly 9 is divisible by 3, right? You can eliminate that. 6 is also divisible by 3, you can eliminate it. 3 is also divisible by 3, you can eliminate that one. 7 you will have a remainder as 1, and 1 and 5, these two sum, it becomes 6, that also get cancels. Instead of adding, you can do the cancellation also. So now 1 plus star divisible by 3. So what are the values of star? As usual, same 2, 5 and 8 only, you will get the same answer. So how many pairs of star is possible means 3 different pairs. It can be 2, 5 and 8. How many values of star is possible means, or else what is the exact value of star means, they will give either of those 3 options in the given question. What least number must be subtracted from 1672 to obtain a number which is completely divisible by 17? Now we need to subtract a particular number from the 1672 so that that number is divisible by 17. So in general, the general and basic process is you need to divide that 1762 with 17. 1762 with 17. So 17 ones are 17, right? We all know. You will get remainder as 0. As usual, you will get 6 here, good. But 6 is not divisible, so I will take one more 0 and I will import that 2 also. Okay, now I was left with 62. Now 17 3s is 51. So what I will get remainder as 11. Remainder as 11. What is meant by this remainder? This remainder is nothing but the excess value. Excess value. If there is no this remainder, if the remainder is 0, then that number is divisible by 17, right? That means you need to subtract this remainder from the given dividend. Okay, so what you will get? 1762 minus 11, that will be equal to 1751. So 1751 is our number which is exactly divisible by 17. But what is the least number which we need to subtract means 11. 11 is the number which we need to subtract from the given number so that it will be divisible by 17. Next one. What least number must be added to 2010 to obtain a number which is completely divisible by 19? Now in the previous cases, in the previous question, we need to subtract. But in this case, what we need to do? We need to add. So what we need to add? We will check it once. Now see here 2010. It should be divisible by 19. We all know 19 ones is 19. So you will write 1 as remainder. So 1 will come by default. But 11 is not divisible by 19. So what I will do is I will take 0. So this one more 0 comes here. So 110. So 19 5s are 95. 19 5s are 95 and the remainder which I will get is 15. If I want to subtract, I will subtract 15. But in this case, I need to add. That means instead of this 15, if this number becomes 19, then one more 106 it will become and we will get the remainder 0, right? So what is the number I should add to this 15 to equal that to my divisor? 4. That means if I add 4 to 15, then it becomes 19. Then obviously 19 is divisible by 19. So we can easily divide it. So the least number which we need to add here is 4. If you want to subtract, directly subtract the remainder. If you want to add, we need to add something to my remainder so that it will be equal to the divisor. So what is the number which I need to add for 15? I need to add 4 to 15 so that it will be equal to 19. So my answer will become what here? 4. Next one. On dividing 12401 by a certain number, we get 76 as quotient and 13 as remainder. What is the divisor? What is the divisor? Now please see here. So here we need to know one relation. We already know that the relation also, but for your knowledge, dividend, divisor, quotient and remainder. What is the relation between these 4 things? Means divisor into quotient is divisor into quotient plus remainder. This value will be equal to dividend. This value will be equal to dividend. So we will substitute simply those values in this case and we will simply get the answer. Divisor we don't know. So let us assume it as a D only. And what is the quotient they are getting? 76 plus what is the remainder? 13. That will be equal to my 12401. 12401. So now what I can write? D into 76 is equal to 12401 minus 13. So D into 76 is equal to, what you will get here now? 12388. 12388. Okay. So now you can directly cancel it, there is no wrong in that, or else do any other mathematical operation. But my suggestion is you can directly cancel it, there is no wrong in that. I will go with 19 table, or for example 4 table. 4 19s, 4 3s, 0s, 9s and 7s. Now 19 table, 19 ones, 19 ones is 19, and what you will be left now? 11, 119. 119 we will get. 119 means 19 6 are you will get, and then next 57 163. So what is my divisor here? 163. 163 is my divisor here. 163 is my divisor here. Okay, in this manner we will find the answer for these questions. This relation is very, very important here. We already know, but we will use this relation to get the answer for this type of questions. Next one. On dividing a number by 56, we get 29 as remainder. On dividing the same number by 8, what will be the remainder? See here, any number which is divisible by 56 is divisible by 8. Am I correct or not? Any number which is divisible by 56 is also divisible by 8. Is it true or not? Yes, it is true. The reason is very simple, ma. Why? Because 8 is a factor of 56. 8 is a factor of 56. For example, those numbers are very big. We will take small numbers. We all know 16 is divisible by 4, right? And for 4, 2 is a factor. That means obviously 2 will divide 16. Okay, 2 is also a factor for 16, right? That is the case. Same concept here also. Anyway, 8 is a factor of 56. So if it is divisible by 56 means then the number is also divisible by 8. And it will be left with some 29, right? Now we need to check only this 29. That is enough. Now simply check what is the remainder for 29 by 8. What is the remainder for 29 by 8? 5. 5. 5 is the remainder for 29 by 8. So our answer here is 5. No need to worry about the given number. We only check that number. Next, if the number 481 star 673 is completely divisible, what is the smallest whole number in place of star? They clearly mentioned as that what is the smallest whole number in place of star. We will see. 4 plus 8 plus 1 plus star plus 6 plus 7 plus 3. This should be divisible by 9. As I already told you, you can cancel the 9 sum also, or else add completely. It is up to you. First of all, we will add completely and then we will see the 9 one. 4 plus 2, 8, 12, 13. 13 plus 6, 19. 19 plus 7, 26. 26 plus 3, it becomes 29. 29 plus star by 9. What should be my smallest number in place of star? Whole number. That means you can take from 0. So we all know that after 29, the next multiple of 9 is 36. So what is the place of star I should write? 7. 7 is my answer. Or else you can cancel the 9 sum also. 8 plus 1 is 9, so I can cancel that. 6 plus 3 is also 9, I can cancel that. I will be left with 7 plus 4. 7 plus 4 means 11. 11 plus 7 or else star should be divisible by 9 means star value becomes 7 here. Okay. Next. The sum of first 45 natural numbers is, we just now in our previous slides we have written the formula. What is the sum to n natural numbers formula? N into n plus 1 by 2. What is n here? 45. First 45 natural numbers. So that is the reason I can use this formula. So what happens to this? 45 into 46 by 2. 2 ones to 23. So our answer will become 45 into 23. Okay, solve that, you will get the answer. Next one, the sum of even numbers between 1 and 31 is. Now see here, what are the even numbers do we have from between 1 and 31? 2, 4, 6, 8, 10 and so on up to 30. And so on up to 30. So total how many even numbers we have? 15 even numbers. But we have only the formula for first n natural numbers. Do you have any particular formula for first n even numbers? By using this formula we cannot do that one, but we can solve this one with the help of arithmetic progression. Arithmetic progression. What is meant by arithmetic progression? Any series who have the common difference between two successive numbers, then we call them an arithmetic progression. They are in arithmetic progression. Now see here, what are the numbers I have? 2, 4, 6, 8. What is the difference between them? Here it is 2, between two successive numbers. Always 2, 2, 2, right? So that means I can say that this series will be in arithmetic progression. This series is in arithmetic progression. So some concepts we will write about this arithmetic progression. What it is means, generally a comma a plus d comma a plus 2d comma a plus 3d and so on. This is the representation of arithmetic progression. Okay, where we call here a as first term, okay, d as common difference. We will see some of the important observations from this one. Okay, this is d. Okay, Tn. That means if I want to find the nth term in any arithmetic progression, we will use the formula a plus n minus 1 into d. We will use the formula a plus n minus 1 into d. And sum to n terms in arithmetic progression is equal to n by 2 into a plus l. N by 2 into a plus l, where n is number of terms, a is first term, and l is the last term. So we will find all these things here. Now what we have? A is 2. So and nth term, or else the 15th term. What it is my 15th term? 30. Actually here I can directly say it have 15 terms. Where is my first term is 2 and my 15th term is 30. The reason is I know that from 1 to 31 I have 15 even numbers. So same thing I will apply. So what you will write? Sum to n terms in arithmetic progression n by 2. 15 by 2 into first term is 2 and last term is 30 for me. First term is 2 and last term is 30 for me. So what happens to this? 15 by 2 into 32. 2 ones, 2 16s. So 15 16s are 240. So we will take the help of arithmetic progression to solve this type of questions. Okay. Sometimes we will use these concepts. If you don't know the nth term also, we will substitute in this and we will try to get our answers. So like this. Next one. Find the sum of 51 plus 52 plus 53. See, we can solve this one in two different ways. If you know the arithmetic progression, that is very, very simple. Or else if you go with the basic and standard sum to n natural numbers formula also, it is different. See, if I use the first sum to n natural numbers concept, how I can get this? Sum of first 100 natural numbers minus sum of first 50 natural numbers. You can use this formula. Sum of first 100 natural numbers means 100 into 100 plus 1 by 2. So what you will get? Okay, sorry, I need to write this one also, right? 50 into 50 plus 1 by 2. 2 ones, 2 25s. So here what I will get? 50 into 101 minus 25 into 51. 50 into 101 minus 25 into 51. 50 into 101, what you will get? 5050 minus 25 into 51. 25 into 51. 25 5s are 125, 1250 and plus 25. So 1275. You need to subtract these two things to get the final answer. Okay, right. If you know the arithmetic progressions, what is first term for me here? 51. What is last term for me here? 100. And number of terms are how many? 50. So sum to n Sum of n numbers in any arithmetic progression is what? N by 2. That is 50 by 2 into first term plus last term. First term plus last term. So 25's 2 into 25. So 25 into 151. 25 into 151. Anyway, you will get the same answers in both the cases. 25 into 151, what you will get? 151 into 25. 5, 6. Next 2, 0, 3. 5, 7, 6, 3. So you will get here 3675. 3675. 3675. And similarly, if you solve this one also, you will get the same answer. Okay. Next one. The sum of all 2-digit numbers divisible by 5 is. See, any multiple of numbers. Okay, multiples of any number will be in arithmetic progression. Right? Am I correct? Multiple of any numbers will be in arithmetic progression. Now, sum of all 2-digit numbers divisible by 5 are. What is the first 2-digit number divisible by 5? 10. And then next 15, 20, 25 and so on up to 95. These are the 2-digit numbers which are divisible by 5. So, total how many numbers are there for me here? Please observe, up to 95 actually 19 and previously one multiple is subtracted. So, total how many numbers do I have here? N is 18 and first term is 10 and last term is 95. So, please observe carefully. Okay, sum to n terms in arithmetic progression n by 2. N by 2 into a plus l, first term plus last term. So, n by 2 means 18 by 2 into first term is 10 and last term is 95. So, what you will get? 2 ones, 2 19s, sorry, 9s, 9 into 105. 105 9s are 945. So, this is the sum of all the 2-digit multiples of 5. 2-digit multiples of 5. Next one. Find 1 square plus 2 square plus 3 square and so on up to 10 square. We have the formula for sum to n terms, squares of n terms in any natural numbers. What is that formula? N into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. So, here n is what? 10 for us here. So, 10 into 11 into 21 by 6. So, 2 5s, 2 3s, next 3 1s, 3 7s. So, what we will get here? 35 into 11. 35 11s are 385. 385. Okay. Next, find 2 square plus 4 square. Here what you will do? We don't have any formula. Then how we are going to solve these problems? Very simple. Please see here. 2 square plus 4 square plus 6 square plus and so on up to 20 square, right? So, what I am going to do is, I will write it little bit differently. 2 square plus, I will write this as 2 into 2 whole square plus 2 into 3 whole square plus 2 into 4 whole square plus 2 into 5 whole square plus and so on up to 2 into 10 whole square. I can write this one in this manner. Yes, I can do. Now, I will take 2 square common. When I take 2 square common, what I will have here? 1. I have 1, but intentionally I will write it as 1 square. And I will have 2 square here. I will have 3 square here. I will have 4 square and so on up to 10 square and so on up to 10 square. I will have this one. Okay, now just now we calculated the value of this one. What is its value? 385. So, simply substitute that value here. In general, we need to calculate for this, but just now we calculated here. So, directly I will write, use that one. So, 2 square into 385 will be our answer. That means you need to write your answer as 4 into 385. 4 into 385. So, what is the value of 4 into 385? You will get this value as 1540. You get this value as 1540. With this, our first session of this number system was finished. Later, in continuation to this session, we will have units digit, some of the important concepts we will have. Okay, don't miss those concepts also. We will have concepts like units digit, remainder theorem, remainders, right, number of zeros and factors. We will have all these concepts which are very, very important in our number system. So, in our next session, we are going to learn about those concepts, right. Thank you.